coating performance indicator, that's a new idea that we started with 1 year ago. And the idea here is the use case is mainly for painting lines. You see in the photo here, you have several items hanging, being painted, and what they wanted to detect was with the MUR system you can today detect if the line is running or standing still. You could also check if it's running at the correct speed. But not only that, we also wanted to see how compact are we hanging these items. Are we utilizing the full dimensions? Because if you're only hanging one and one sparse space between them, you're not using as much as you need. And why this matters is because these are going through an oven. Today's electricity prices, that's quite a lot of money. So you want as many details passing through the oven as fast as possible, so you can be done as soon as possible and then shut down the oven and save electricity that way. But this might also be usable in other situations where you want to have the physical space filled as much as possible. So what we're looking here is the speed of the conveyor. We're looking at horizontally along the conveyor belt. Are we hanging them as tight as possible, or do we have too large gaps? We will for each customer will specify what is an acceptable gap. In this example, they wanted 15 centimeters. So these gaps here will be ignored, but for example, the gap here will be recorded. But we're not only looking at gaps horizontally, we're also looking at vertically filling, meaning how much can we utilize all vertical space on this conveyor belt. So mathematical explanation, this one is somewhat similar to the idea of OEE, but here we're looking at the horizontal and vertical filling, hanging items as close as possible. Then we're also counting how that the conveyor is running and not standing still. For example, if there's not enough time to put items up, you have perhaps too few personnel, or items are not arriving in time. That means they might need to stop the conveyor to fill it up, and that's not good, so we want to track that. And finally, just want to see also that the speed is correct. In practice, we found the speed was almost always constant, but it's always good to have a number on it. And the sensor is definitely used to calculate this horizontal coverage. So what we get out of this system, before I show the installation, is the conveyor running at the right speed, an easy stop and running graph like this. But then we can also look at degree of filling. So in the top first line here, we can see when it's standing still and when it's running, like this. But the second one, you see we have additional information. We have these darker areas, and these are gaps where the conveyor is running but there's nothing on it. So if we can get rid of this big gap here, we can shorten the time for the oven. And finally, we have this graph below showing both horizontal and vertical filling. So if you have only upper half of the conveyor filled, it will only go down halfway, indicating. So for example, here we can see many variations indicating we have not filled it completely over this time, but over here we can see we have filled it 100%, as much as possible at least. And the results can be shown on the info screen. This is from our Swedish customer. And we have the same lines here. Here we also show the speed. But then we can show this CPI value that is the combination of all these factors of the horizontal and vertical filling, of the speed of the conveyor and stops. But we can also extract individual components of these measurements. For example, we're looking at only filling, and here we express it as square meters, meaning along the conveyor, how many square meters are we filling with items to be painted, and what are we missing. As well as normally with the MUR system, you have stop codes. We can show how different stop codes are appearing, what the reason are for these gaps here. Here we can see they have started color coding them in the different stop codes. And this one works the same as the stop code entry works today at your MUR-Boxes. So to get this working, here we have a few more items we need. We need a measurement wheel to measure the movement of the conveyor. It's not only to measure speed, but also to calculate the square meter area being covered. And to detect how much is hanging on below the conveyor belt, in this example we have 4 optical sensors, nothing fancy, just standard optical sensors. And because we have 4 sensors, we calculate that they represent 25% of each vertical filling, which means we get a quite rough resolution vertically, but many times it's enough. We could add more sensors, up to 10 sensors, get the 10% resolution vertically. However, horizontally we get centimeter resolution because of the measurement wheel on the conveyor. So we need the measurement wheel on the conveyor. We need 4 or 10 optical sensors. And that's the external hardware we need. All these are connected directly to the MUR-Box. So you need a MUR-Box with 5 to 11 available inputs. So you might have a MUR-Box 3.0 measuring one machine, could connect the other 5 inputs for this CPI solution. And in addition to that, you need 3 machine licenses, because the data we collect using these optical sensors requires 3 licenses to store the data. And then we will support you with getting the custom box script that's needed to summarize this data in the right way. And then we can also help you with setting up info screens to show this, what you saw before, different types of presentation. And doesn't have to be all at once here. Many times it's good enough to start looking at, for example, just this gaps detection, and have that as a starting point. And once you have started addressing the horizontal gaps, we can start looking at the vertical gaps.